I was sitting down, relaxing, having a good time, then all of a sudden, boom, knocked over a glass of water. After a good enough excuse, I discovered to tell my parents that gravity had ruined my day. Was gravity just something that pulled everything down? Today I'm going to be talking about quantum gravity and how it affects everything in our lives. Now, gravity is just one of the four forces of nature, the first being electromagnetism, which focuses on the attraction between atoms, the second being the weak interaction, which focuses on atom decay, the third being the strong interaction, which focuses on binding the nucleus together, and the third being gravitation. The textbook definition of gravity is the attraction between objects having mass. However, that's pretty broad. Any object can have mass. I have mass. You have mass. We all have mass. But we don't see anything coming towards us. It'd be pretty dangerous. However, we can explain that through we're not big enough. Our Earth, for example, is big enough for the fact that it's able to attract the moon, and the moon is able to attract us as well. But can we go deeper? Now, to explain gravity, I must explain space-time, and explain space-time, I must explain the relation between space and time. Now, to move through space, you must be moving through time. For example, I can't move my hand to here without moving through space or time. There is a certain set amount. And we know that our three dimensions are length, width, and height, but it's proposed that the fourth dimension is time, for you cannot move through either of those without moving through time as well. That is why we have come up with the space-time, where it is said that all of space and time are just put into a single string, and you cannot move through it without moving through this string right here. Now it is said that gravity is a warping of space and time, meaning that, for example, gravity, if I throw something, the object would curve due to the warp, and time would warp as well, either slowing down or speeding up. Now, what I just explained is special relativity, which explains the relation between space and time, space-time, and I also explained general relativity, how gravity is the warping of space-time. Imagine you're in a rocket ship. The thrust is responsible for making you weigh 70 kilograms inside. However, how are you going to be able to tell if that's different from a gravitational field? The results are indistinguishable. From that, we're able to decipher that acceleration works the same as gravity, as you weigh the same in both situations. From this, we can deduce that gravity is nothing more than a field of acceleration. Now, the main problem we have with fitting quantum gravity and quantum mechanics together is that quantum gravity focuses on the macro level of the universe, while quantum mechanics focuses on the micro level. However, hopefully one day we will be able to fit them together. Until next time, I'm Horace Nawaz.